Hi guys, welcome back to my channel, the Boy. It's another Simulkuy episode, and we are still on the process simulation utility series. Today, I would like to talk about property balance utility, one of the utility that you can use if you want to observe or you want to evaluate the balance of mass, energy, or any other property in your simulation. So you could choose also the scope of your evaluation, whether it is a plan-wide evaluation, the entire flow sheet, or you want to have it specific for a certain equipment, for your reactor only, for the distillation column only. So this is the interesting part of this utility. Okay, so without further ado, let's go to the demonstration. Okay guys, so this is the file that I will use to demonstrate the property balance utility. So this is a TEG unit, where we have one conductor or absorber to absorb the water from gas and one regenerator or regenerate the TEG solvent. Okay, so we will add the property balance utility. First, we will add the variable that we want to observe. For example, here I want to observe the mass flow of water in the system. So for the insert variable, I will search for mass flow of H2O. Okay, after selecting this variables that we want to observe, we need to select the scope of object. So we can select the entire unit operation inside the case. It means we want to observe the entire flow sheet, something like this, and then we click accept list. Then we will look at the result at balance results. So we could see here in the inlet and outlet, inlet material stream is this one, inlet gas and also water to saturate, as well as the makeup TEG located here. While the outlet material stream is this FWKO, sour gas, water dew point, and also TEG only. So we could see where does the water going, from water to saturate, which is this stream. At the end, it will be going to the FWKO and also sour gas by 50% and 50%. We could change also the scope, not flow sheet wide, but we want to observe in a certain area. For example, we want to know only at the TEG contactor. For the scope of object, I will remove all, and then I will change into only the TEG contactor. Something like this. So now we could see that the scope will be different. Inlet material stream will be the TEG feed, which is this one, and also gas to contactor, while the outlet is this dry gas and also rich TEG, but with a different name. Okay, so we could see at the gas to contactor we have 9 kg of water, TEG feed 5 kg of water. With the outlet, most will be going to the number 2, which is this rich TEG. Okay, if we take a look here, basis to mass flow, we could see that the H2O value is the same, 14.044. Okay, so this way we could also observe the balance between the inlet and outlet. Of course, because this is an ideal steady state model, the balance will be 0. Another thing that we can do is we can observe the balance of energy stream as well. So by looking at the energy balance, we could see that the energy is also conserved between the inlet and also outlet. Since we only select the absorber, what we have here is only the enthalpy of each inlet and outlet stream. But if we select all of the component, something like this, so we could see that the energy is not only from the enthalpy, but also coming from the equipment. For example, this pump Q, and then the reboiler duty, condenser duty, everything is included in this energy balance calculation. And we also could see that the inlet and the outlet have a balance of energy. The next thing that I want to demonstrate is about the formula. So for example, we want to observe the flow rate of H2S or HCO2. but in a different way. Yeah, we don't directly spec the component mass flow, but instead we will multiply between the mass fraction times mass flow. We could do it by formula. For example, here is mass flow, and then the master component mass frac of CO2. Okay, so we could see here our mass flow, the variable is noted as V1, while the component fraction of CO2 is noted as V2. So when we write the formula, we should write it in the form of this V1 and V2. To get the mass flow of CO2, it means we need to multiply mass flow and also the component mass frac of CO2. So I will put here V1 times V2. Okay, and I will describe this as mass flow of CO2 with the variable type of mass flow. In the balance result, we could see mass flow of CO2 here. Yeah, and we will get the result. So the inlet gas we have 600 CO2 with the outlet. Most will going to the water dew point, and some of it is in the sour gas. The thing that you should note also in the formula, each formula will have their notation. This notation is useful if you want to create a formula based on the previous or the other formula. For example, here I want to create an arbitrary formula of 0.9 times the result of our first calculation. So times F0. So here we will get in the balance result. Yeah, the number is like 90% of the F0. So this is the F0 and this is the F1. Okay, so I think that's all for this video. I hope you get more understanding on property balance utility. This is a very interesting tools if you want to evaluate the mass or energy balance inside your system. If you want to make a big scope, the entire flow sheet, it can do. But if you want to make the balance in the smaller scope, you also can do it in this property balance utility. Okay, thanks for watching and see you in the next episode. Bye bye.